Hello everybody. In this session, we are going to learn about differential amplifier concept. At the end of this session, students will be able to describe the concept of differential amplifier and its operation in differential mode and common mode. So this is the content of this session. So let us start with the definition of a differential amplifier. So what is a differential amplifier? The differential amplifier amplifies the difference between two input voltage signals, and it can be used in various applications. So the amplifier which amplifies the difference between two input voltage signals is called as a differential amplifier. So this differential amplifier can be used in various applications, like it can be used as a basic building block of operational amplifier to construct an operational amplifier, as well as it can be used in an input stage of biomedical instruments like ECG. It can be used in input stage of power oscilloscope, and it is also used in various instrumentation systems to compare two voltage signals. Now this figure shows a block diagram for ideal differential amplifier. It has two input terminals and single output terminals. So to the two input terminals, the two input voltage signals V1 and V2 are applied with respect to ground. And from single output terminal, the output voltage VO is taken, so that is directly proportional to the difference between two input voltage signals V1 minus V2. And the polarity of output voltage depends upon the difference between two input voltages, polarity of two input voltages V1 and V2. So the effective input for a differential amplifier is designated as VD, that is the differential input voltage. So that is the difference between two input voltages V1 and V2. So ideally, the output of differential amplifier is directly proportional to the difference between two input voltage signals. Now let us define some basic parameters or terms related to a differential amplifier. The differential input signal VD, so the difference between two input voltage signals V1 and V2 is called as differential input signal. The differential gain AD, the next parameter is differential gain AD. So it is a gain with which differential amplifier amplifies the differential input signal is called as differential gain. It is designated as AD. So AD is equal to the output voltage VO upon the differential input voltage VD, where VD stands for V1 minus V2. Next parameter, the common mode input signal. A common signal applied to both the input terminals of differential amplifier is called as common mode input signal. The output signal of a differential amplifier depends upon both differential input signal as well as a common mode input signal in case of practical differential amplifier. So it depends upon differential input signal as well as the average voltage level of the two input signals V1 and V2. So the common mode input signal, so that is a signal commonly applied at both the input terminals. So that can be mathematically defined as Vc equal to V1 plus V2 upon 2, the average of voltages applied to the two input terminals of a differential amplifier, designated as Vc. The next parameter, common mode gain, designated as ACM, the gain with which the common mode input signal is amplified by differential amplifier is called as common mode gain. So ACM equal to the output voltage of a differential amplifier VO upon the common mode input signal. The best example of common mode input signal is a noise signal. So that can be present everywhere in the surrounding atmosphere. So that is commonly applied to both the input terminals of a differential amplifier. So for common mode input signal, the differential amplifier should provide very less output voltage. As far as differential input signal is concerned, it should provide maximum output voltage. The next parameter is common mode rejection ratio. So common mode resistance ratio, designated as CMRR, it is a ratio of differential gain AD to common mode gain ACM. So it is a figure of merit of differential amplifier. So this common mode resistance ratio indicates the ability of differential amplifier to reject a common mode input signal like a noise signal. So the net output voltage of differential amplifier VO equal to, it depends upon both the differential input signal as well as common mode input signal in case of a practical differential amplifier. So VO equal to AD into BD plus ACM into VCM. So output voltage depends upon both the differential input signal as well as common mode input signal, and CMRR should be as high as possible. So this is possible only when ACM, that is common mode gain, is as less as possible, ideally 0. So ideally CMRR is infinity. Practically it should be as high as possible. Now let us discuss basic differential amplifier. Now this figure shows the circuit diagram for a basic transistorized differential amplifier. It is designed using two identical common emitter biased transistor amplifiers using the transistor Q1 and Q2 of same type. So circuit is bilateral symmetrical, and it is biased using a two DC power supply of equal magnitude and opposite polarity, plus VCC and minus VEE. The output voltage is taken between the collectors of two transistors Q1 and Q2. Now let us first discuss the working of a differential amplifier in differential mode. When two input voltage signals of equal magnitude and opposite polarity are applied to differential amplifier. When two input signals are different, now let us consider the differential input signal Vin1 equal to minus Vin2. So that is two equal voltages of equal magnitude and opposite polarity are applied to the two input terminals of a differential amplifier at the base terminals of transistor Q1 and Q2. So as transistors are connected in common emitter circuit configurations, the collector signal voltages are out of phase with respect to their base voltage signals. Now consider a positive half cycle of input signal. During positive half cycle of input signal, the input for the transistor Q1 is positive. At the same time, the input voltage for transistor Q2 is negative. So corresponding to this, the voltage at the collector of Q1 is negative and voltage at the collector of Q2 is positive with respect to the input signal. So output signals are out of phase with respect to input base signals. So the input signal applied to base of Q1 produces a positive voltage across emitter resistor RE, and at the same time the negative voltage at the base of transistor Q2 produces a negative voltage across RE. So two equal and opposite voltages are developed across RE. So they cancel each other. So RE does not cause any negative feedback. The current flowing through resistor RE is equal to 0 because the voltage appearing across RE due to the first input and second input, Vin1 and Vin2, they cancel each other. So RE does not cause any negative feedback. So the gain of overall differential amplifier will be a maximum. So output voltage is taken between the two collectors that is at the collector of transistor Q2 with respect to the voltage at the collector of transistor Q1. So for differential input, the gain of differential amplifier is maximum. And now let us discuss the operation of differential amplifier in common mode operation. When input voltages of equal magnitude and same polarity are applied to the two input terminals of a differential amplifier. So that is nothing but the base terminals of transistor Q1 and Q2. Now consider when both input voltages are positive with respect to ground. So during a positive half cycle of input signal, the voltage is positive at the base of transistor Q1 as well as at the base of transistor Q2. So as input signals are in phase and of equal magnitude, their collector signals are also in phase and equal magnitude. So the net final output voltage of overall differential amplifier, so that is taken at the collector of transistor Q2 with respect to the voltage at the collector of transistor Q1. So the output voltage will be ideally 0. In case of a practical differential amplifier, the output voltage of this differential amplifier for common mode input signal is not 0, it will be very small. So that is due to slight mismatch in the two half sections of the differential amplifier circuit, due to some slight difference in the electrical parameters of two transistors of same type. So we are getting unexpectedly some small output voltage between the two collectors of transistor Q1 and Q2 when both input signals are equal and of same polarity. So in this case, as the two input signals of same magnitude and same polarity produces equal voltage with same polarity across common emitter resistor Re. So these voltages due to Vin1 and Vin2 will add with each other across Re, and Re will cause a negative feedback at the input side of this amplifier. So due to negative feedback, the gain of overall gain of amplifier will be very less, small. So the differential amplifier will provide a minimum output signal between the two collectors of a transistor Q1 and a Q2. So for common mode input signal, due to negative feedback that is caused due to Re, the gain will be very less, so output will be very less. Ideally, output should be 0, but practically we are getting very small output. Now the students can pause video here and think over this question and try to answer this question. So which component of differential amplifier causes a feedback and state its significance? The emitter resistor Re causes a negative feedback for common mode input signal like a noise signal. So noise signal is a signal, electrical signal having random frequency and random amplitude, which is present everywhere in the surrounding atmosphere. So Re causes a negative feedback. So therefore a voltage gain, that is common mode voltage gain ACM, will be very less, and CMRR, common mode resistance ratio for a differential amplifier, will be very high. This is the reference. Thank you.